Hello everyone, welcome to today's edition of our Enterprise Database Migration Lab. For today we are exploring networking for secure database connectivity, and I'm going to show you why we need a secure network for our database connectivity. Likewise, we are going to use Terraform to create network and firewalls. Building a secure network to host the database server is more often than not the first step. To build a secure network configuration, it is good for all the resources to be in a project. A project in GCP contains one or more virtual CPUs, and each virtual CPUs contain one or more subnets. You can use multiple networks to easily isolate machines from each other, and firewall rules can control which machine can communicate using designated ports. A default network is created when you enable your compute engine service, but you can also create custom ports or custom VPC network in your project. With firewall rules, you can specify target and sources. So there are different ways to specify target and sources using firewall rules. That's an overview of networking for secure database connectivity. So let's talk a little bit about Terraform before we get started. Terraform is a tool from HashiCorp that allows you to automate the creation of resources. It is supported on all major platforms, and it is included in Google Cloud Shell by default, and it does not require any installation or separate servers in order to run. It makes tasks easier and automated. Terraform uses a collection of template files to deploy cloud resources. You can create variables for your Terraform deployment. This enables us to easily change settings by just changing the variables. Variables can be set in templates or at runtime. There are different Terraform commands that we have. One of them is Terraform init. This initializes the Terraform working directory. You can run it from the folder with the Terraform files. Terraform plan. Generate and show an execution plan. Terraform control the orders in which resources are created. We also have the Terraform apply. This builds or changes the infrastructure described in the templates. You can use an auto-approve parameter flag to prevent yourself from being prompted when you want to approve a plan. You can just use Terraform apply auto-approve. There's also a Terraform destroy auto-approve. This destroy Terraform managed infrastructure, and it is tracked in the .tf state file. A secure environment allows only known clients to access the database through firewall rules, and we'll be using Terraform to create networks and firewalls. Here are some common pitfalls to avoid when configuring network. Try not to use the IP range 0.0.0.0/0 because that's a general IP range that falls into a whole lot of other IP ranges. Use tags or service accounts to specify targets. So you can use tags like allow ICMP, allow SSH, allow HackDP to specify, or just use service account to specify the targets. Likewise, don't use external IP address on virtual machines that do not need them. So a virtual machine that you don't need to connect from outside, it does not need to have an external IP address. This is because external IP address costs more money, and there's also charges for ingress. You can use CIDR range that are small when configuring subnets. This helps us to reduce conflicts. Likewise, always use SSL when communicating from outside Google clients. For communication within Google Client, you don't need to use an SSL service because encryption within Google Cloud is by default. Likewise, use a VPN or Cloud Interconnect to connect on-premise network to Google Cloud. Following the strategies I mentioned would help you avoid the common pitfalls or the common issues that happen when configuring network. So let's dive into our lab for today. The first thing is to start the lab. So I just have to complete this. The next thing is to open in an incognito window. Next. And I copy my password. Paste it here. I understand. Here's my dashboard. So just agree to the terms and conditions. This is the dashboard for my GCP project here. And let's get started. The first thing we want to do is use Terraform to automate network creation. So to do that, we have to first activate our Cloud Shell. To activate your Cloud Shell, click on this here. After you click on Activate Cloud Shell, then continue. So it would help us provision our Cloud Shell machine, and thereafter we connect to our Cloud Shell instance. Connect this. Here we are on Cloud Shell. First thing we want to do is this command. So this command is going to make a directory of named Terraform network. It's going to name a folder, and we are going to cd into this particular directory. So with that, we create this. So thereafter, we'll create files that we'll be using for this lab. So the touch command creates files. So touch provider.tf, it creates a file named provider.tf, which is the extension for Terraform. Paste all this. So automatically it has created all these files for me. Then if I want to list them, I can use the ls command, and these are all the files I wanted to create. To view those files, I would open editor, then open the editor in a new window. So here is my editor. It's loading. So this is my editor, and you would see all the files I just created. So take a look at Terraform network, all the files that I created. This is the folder that is housing everything. Yeah, good. So the next thing we want to do is we want to enter the following code to configure the Google Cloud Terraform provider, and we'll be saving that in the provider.tf. So this is the provider that we are using, and we are configuring the code here. So on our provider.tf, paste this here. Then you can decide to use Ctrl S or just leave it alone and it will save automatically. Sometimes it's saved by default. So the next thing we want to do is we want to set these variables under our variables.tf files. And if you take a look at this, this is the variables, the project ID, it's a string, and this is the description. So the subnet, the variable, this GCP region _1, it's a string, and that's the description. So, and the rest for others. This is the public network that I'll be using. The variable name is the subnets _CIDR_public. So just copy everything here and go to our variables.tf file. Under our variables.tf file, paste this here. Next thing we want to do is we want to open our terraform.tf vals file and add the following code. So under our terraform.tf vals, paste it here. Terraform.tf vals file is typically where we assign variables to. It's typically where we assign values to the variables we created here. So you can see the subnet here, assign a value here, the GCP zone 1, assign a value here, GCP region, assign a value, and the GCP project, which is also assigned a value here. And this tallies with my project ID. So copy this and under Terraform.vals, paste it here. Next thing I want to do is we'll open a VPC network public.tf file and add the following code. So this is us setting the necessary configuration for our public network that we are creating. So the name is a public VPC, that's the name. Auto create subnet, we are setting it to false. The routing mode is global. And this is also the subnet. We are creating a subnet. The name is public subnet 1. would set an environmental variable in this subnet VR here. We have the name and we have the region here also. After setting all these network configurations, you can take a look and see if your default variable network is on your GCP project. So there's a default variable network we have under VPC network here. So you can see the default is created for us already by default. What we want to do is we want to open terminal and we want to cd into the Terraform networks folder. I'm probably there already, so I'm there already, but I'll just run the command once again and I'm still there. So the next thing I want to do after that is to initialize Terraform. So let's initialize Terraform with the Terraform init. So when you initialize Terraform, see it loading and it will tell us that Terraform has been initialized. The next thing we can do is Terraform plan. So when you run the code Terraform plan, it will show us the order in which our services will get created. Authorize this. So here are the two services that we're creating. The first one is the public VPC from the configuration we set, and this is also the subnet region that we are doing, the subnetwork, the public subnet one that we are creating, which is just as we want. So after that, we can use the Terraform apply auto approve. So with the Terraform apply auto approve command, it's going to automatically apply and create all these resources. So just let's wait for it to get completed. Yes. So our apply has been completed and the necessary network has been created. So I've completed all this. So for us to be sure that what we created is actually there, what we can do is we can check our console and go to the VPC network and let's see if we have another VPC network here. So when I click on refresh, you can see I have the public VPC with one subnet in it. So when you click on the public VPC, you would see the one subnet we have there, and this is the public subnet one that I created, which means what we created actually works. So the next thing I want to do is I'm just going to delete all this and destroy it. And to destroy that, I'll use the Terraform destroy auto approve also. So when I do that, it will delete everything that we've created. So let's wait till it's complete. Okay, so it has destroyed the resources here. So to be sure, take a look at it. You can see this and this is there. Let's just refresh and you see one of them has come. So what we destroyed has gotten destroyed and it's no more showing here for now. We'll probably still recreate it one more time, but let's keep going. So let's confirm if we've done this. So we've used Terraform to automate network creation. Next thing we want to do is to use Terraform to create a firewall rules. And it is a network that has a firewall rule. So we'll also create a network once again while we are doing this firewall rule. So on our VPC firewall rules public.tf file that we created, we are going to add this firewall rule, which means we are allowing SSH into this machine. And these are the ports and the protocols. And this is our source range. We are using a generic source range to allow all IP address. That's fine. This is just a test lab. So I'm going to go back to my editor, and under my firewall rules, paste this here. So I still need to add more firewall rules. Another one is, since Windows machine use RDP, not SSH, so we want to also add RDP firewall rule to enable RDP. Just the same, just it's something similar. You allow RDP and you put the necessary tags that should allow RDP, and also this is the IP address ranges. So we still have to allow some other thing. So we want to also allow ability to ping into our virtual machine. So with this, allow pinging, and this is the allow ping from everywhere. So this, you can see the source screen, and the protocol is ICM. We've written the template and the configuration for all our firewall rules here. And the next thing we need to do is to also plan and approve it like the other one. So I'm just going to go back to my Cloud Shell and run the Terraform plan. When I run Terraform plan, you can see it's now 5 networks. The VPC network we are creating the first time, and the sub network plus the 3 firewall rule, with the first one being allow SSH, the second one being allow RDP, and the third being allow ping. So let's see. So you can see the first one, we have the allow ping here, then we allow RDP, and the next one is the allow SSH, and we have, this is the public VPC we are creating, and this is the public subnet one we're going to do. So here is it. So the next thing we want to do is Terraform approve, Terraform apply, then auto approve. So it's going to add these 5 services that we specified. And you can see that 5 resources has been added, 0 changed, 0 destroyed. So let's see if we've also completed these tasks. Task also complete. For task 3, we want to use Terraform to create virtual machines. And in order to use Terraform to create virtual machines, we have to configure our random ID generator.tf. So go back to our Cloud Shell, go back to our Cloud Editor. Under this, specify it here. So the resources random ID, the instance ID, and the byte length is 4. So the next thing we want to do, so basically what this does is that it uses the Terraform plugin to generate a unique name for our virtual machines. So it's generate a unique name for the virtual machines per project. I'm going to like append a random ID at the back. We want to create a virtual machine in the public network. So for that, under the test server linux.tf, which is here, test server linux, we are creating a compute engine instance here, and we are naming it the test server linux. So the name is going to be public test server linux. It's an F1 micro, that's the machine type. The zone is the GCP zone that we specified from our variables. So this from our tf.var, this GCP zone, it's here, and other information as expected that we specified here. So this is just it. So the next thing we want to do, so if you take a look at this, you see that the output variable will return the name of the internal and external IP address. So there's an output here, it's going to return the external IP address, it's going to return the internal IP address. And this machine is tagged with allow SSH tag, so you can also connect to it. So on the firewall we use an allow SSH service. So this is just what we need to create a virtual machine. So after we've done with the old configuration, the next thing we want to do is, as usual, we go back to our Cloud Shell, then we run the Terraform apply, or you run the Terraform plan first. So if you have something like this inconsistent dependency log file, what's happening is just that you just need to init, you need to run the Terraform init again. So I'm just going to run the Terraform init to reinitialize my Terraform. And after my Terraform has been initialized, then I can run the Terraform plan. So running the Terraform plan, you would see the new services that are getting created. The first one being the test server Linux, which is the compute engine instance we are creating, which we are naming the public test server Linux. And after that, we are also creating the random instant ID. So these are the two services that we are doing. Both of them add up to one. The next thing we will do is the Terraform apply auto approve command. So, and these two services get created. So it's creating. Let's wait for it to get created. Yes, it has been created, and you can see the external IP address, see the name, the public test server Linux, and this is the ID that was auto-generated. This is the name of the external IP address, and this is the one for the internal IP address, which is cool. Let's keep going. So let's see if we've completed this task. So you can see it's completed. Oh, so we can also check if we can SSH into this particular instance that we created. So to do that, I'm just going to go to the instance that we created. So when you go to the compute engine, virtual machine instances, so you'd see the instances that we created now. So you can see the name, the public test server, which corresponds to the name here. And when you click on it, you'd see the informations under the virtual machine instance. So here we are. Let's see if we can SSH into this particular instance just from here on our SSH menu. So let's click on SSH, and we should be able to SSH because we've allowed SSH tag. So let's see if it's going to establish connection, and you can see here we have the SSH browser. So we don't need to do anything. This is just to test if we can SSH into it. So I'm just going to exit from this. Yeah, exited. So the next thing, and which is the last task, is to use Terraform to create a private network. And we'll basically more often than not be doing this on our own. So we'll use the knowledge we've learned from creating a public one to create a private one. So just following the instruction here, in the variables.tf file, add a variable for the public subnet IP range and set its value in the terraform.tf vals. So which is the first step. So going back to our cloud editor and coming from the variables.tf, on our variables.tf, the first thing we want to do is we want to define a subnet for our private. So I'll copy this and I'll paste it. Then I'll change this to private. So change this to private. Then change this also to private. This is just the comment, but we are renaming this variable subnet CIDR private, and the description too should change. This is the private one now. So after doing all this, we also have to also set a value for it under terraform.tf var. So come here, same, let me just copy this and edit the value as appropriate. So this is going to change to private, what we set under the variable just now. And I'm going to use a different IP range for this. It's going to change that to 2. Then Ctrl S, or it saves automatically, typically saves automatically. So we are done with this first part. The second part is to duplicate the VPC network /public.tf file and change the name and variables appropriately. So now, using this VPC network public, we'll use it to create a VPC network private. So let me first create a new file. You know, I said you can create a new file by using touch VPC network private.tf. That will create a new file for you, and you can just create a new file from here by using the VPC network /private.tf, and here it get created here. So we have to duplicate what is in the public to the private and change the values. So I'm just going to copy everything here, paste it in the private, paste in the private. So after pasting in the private, I have to change the namings that are here to show that it's actually private. So everything here, I want to change them to private. So I'll just try to use the find and replace command. So from here, I'd say everything that has public should replace it with private. And don't forget to specify the file so that it does not change the one what is not supposed to change. So the files to just change is this one, vpc/network/private.tf. So I just wanted to change everything only here just alone, and this is 1 2 3 4 5 6. We have all the 6 here, 1 2 3 4 5 6. So press this and okay. So it has changed all the instance that the public occurred to private, which is what we want. Yeah, we are done with this also. Want to use the public firewall as a guide and add the firewall rules for the private network that we are creating. So from here, this is the firewall rule we have here. This is everything here. The next thing we are going to do is create a new firewall rule for private. So from the new file, once again, name it vpc firewall rules, then private.tf. So after that, then we copy everything on our public to our private before we begin editing. So we'll use this as a guide. Paste it to our private. So looking at the instruction here, it said in the source section range, in the source range section, don't allow traffic from all sources. Only allow traffic from the public subnet IPCIDR range. So we only want to allow network from the public IP address we created then, and not just any network. So this should change to allow SSH from public IP we created then. This, since we are dealing with private now, I should change everything here to private. Change this to private also. Change this to private. Just the one by one. So under the source range, what we want to do here is that we are using the source range of the public IP address that we created, and since it's a templated value, we just need to come here and then call it. So to call it, you use the $, then using a curly bracket, close the curly bracket also, and the name of the variable is var.subnet CIDR. So this is just it typically, this thing that is here. Copying the public one, since we are using the public one here. So where are we? On the private. So just paste everything here, this portion. So this is just what we need to do. You can take a look at it to see that you are using the correct thing, because the instruction tells us to allow traffic from the public subnet IPCIDR range. So that's why I'm only allowing traffic from here. So just the same thing, copy it to other places that are useful here. This is for the allow SSH. So here also, I'll paste it here. Here also, I'll paste it here. And don't forget that I may need to update all these comments. So you say allow IDP from public IP. Then all this instance that public is showing, I'll change it to private. Don't forget to do that. Then this also private. So this is done. Then from here, so allow ping only from everywhere. Do we need to use a ping here? Let's see what the instruction is saying. Don't allow traffic from all sources, only allow from this. Okay, so it would also allow ping only from the public IP. So update this comment, then change all this to private, change this to private, change this to private. Then yeah, looks like we are good. Just take a look at it. Everything I'm supposed to show private is private. Yeah, we are fine now. So after that, we have to create a test server in the private network using the public one as a guide. So this is the test server we created here, this stuff that is here, and would create a similitude for it using the private. So since this is supposed to be in this public test server Linux file, but due to the configuration that we set here, it's in this file. So what I'm just going to do is that I'm just going to rename this public with the private one. So I can just rename this file or just create a new file. But let me just rename this and rename it back to private. And you can see that it's empty. It's typically empty. This private is typically empty. So what I'm going to do is I'm going to copy the configurations here and paste it on the private one and edit it as expected. So this, the comment to change here. This is the private one, and the name of the private that we are using is the private test server. So I'm going to add a private here with my, then also change this one to private. So what else do we need to change? So this public should also change to private. Make sure you change everything. This should also change to private. Then this text server linux.name, the name of what we are using here is private, so I'm just going to add the private and the tag also. So yeah, why it is this way is because what we copied it from is test server linux, and that is it here. But now we are using a private test server linux, so I'm just going to add the necessary tags to it and take a look at it to see if we are okay. There's a mistake here. Let's see. I think we are good to go. Okay, let me go over the instruction once again. We've done this, we've also done this, we've done this, we've done this. Yeah. So the next thing, after we are done with the configuration, as you would expect, the next thing is to go to our Cloud Shell. And so the next thing we want to do is to connect to our Cloud Shell, and here we are on our Cloud Shell. So what we just need to do is also run the Terraform init once again. So after running the Terraform init, are we good to go? Okay, that's fine. So what we can do is the Terraform apply. Let's run the Terraform plan first. We have been duplicates somewhere. Okay, this is also correct. Let me take a look at this one here. Oh, this is what's happening. I was supposed to also add private here. Adding private here. Adding private here. And I would also add private here. So please make sure you are taking a look at it. I am making, and make sure you add it to everywhere it's supposed to be. So I was supposed to include private here, because when I do not include private here, it's showing two outputs. It's showing two outputs. It's conflicting with what is here. Yeah, which is good to see. Next thing I want to do is the Terraform init command. From the Terraform init command on our Cloud Shell here. So let me reconnect our Cloud Shell instance. So the Terraform init, and here you see our Terraform is as initialized. Then the Terraform plan. Let's see the plan for what we are creating. Nice. So you can see we are about to add 6 configuration. One is the private subnet, the private VPC we created. The third one is the private test server Linux, which is the virtual machine, private virtual machine, and the firewall rules, the allow SSH, allow RDP, and also allow ping, making it 6. So good to go. Now we can run the Terraform apply auto approve. So running the Terraform apply auto approve, you can see it's creating it for us. Just wait for it to get created. Still creating. That's a whole lot of service. Yeah, so we've created the 6 resources that we want, and let's take a look at them on our console before we even go to the next step. So here's only the public virtual machine instance. Let's just refresh this and see if we have our private now. So you can see we have our private also with the ID that has been generated for it. So looks cool. So one thing we can try is when we are building the privates, we want to only SSH from the private IP address of this, from the IP address of the, we only want to SSH from the IP address of this 10.1.1. So if you attempt to SSH here, it shouldn't go. So let's see. And you can see your connection will most likely fail. Virtual machine is missing firewall rule allowing TCP ingress from 0.0.0/0 on port 22. So that is because we are only allowing it to go from the range of the other one. So I'm just going to wait and see what's happening, but it should definitely fail. And you can see it's just eventually failed, which shows that it's not working. So the next thing is just to check if we've completed this, and I think after that we are done. Yeah, so we are 2. We've probably completed all this lab, tax 1, tax 2, tax 3, and tax 4. Just going to see if we have the final score here by checking my progress. Yeah, so we are good to go now. We have our 50/50. Great. And thanks for staying true to the end of this lab. So the 2 major takeaway from this lab is, the first one is we knew how to use multiple networks and firewall rules to control access to machine and database. And you should also know how to use Terraform to automate resource creation in Google Cloud. And that's typically all what we want to learn from this lab. Thanks for staying true to the end of this lab. I hope you've enjoyed all of 2 things, and I hope you've known how to create both public and private virtual CPUs with the appropriate firewall rules in each. Enjoy this lab. Make sure you smash the like button, comment your thoughts in the comment section, and share with your loved ones. See you in our next series on migrating enterprise database lab. Bye for now.